So now we have seen in the previous class regarding the problems on with replacement. Now let us see the problems on without replacement here. So to draw the samples from the population without replacement, the formula is here capital N C small n, where capital N is the population size and small n is the sample size. So if you see the question here, a population consists of 5 numbers 2, 3, 6, 8 and 11. So draw all possible samples of size 3 without replacement from the population, right? Then we have to find the mean of the population mu, standard deviation of the population sigma, mean of the sample distribution of means, that is mu x bar, and standard deviation of the sample distribution of means. So what we have to notice here of sample size 3 without replacement. So this point is very important to solve the problems of random sampling. So here the population size is 5 and the sample size is here 3. So first we have to find the mean of the population. So mean of the population is given by mu. The formula is summation x by n. So here again go to the regression mode linear and give the 5 values here 2, 3, 6, 8, 11. So 2, 3, 6, 8, 11 and press shift 1. So again you will get summation x square, summation x. So first you want the summation x, so press 2 equal to, it is 30. So here 30 by 5, of course it is 6. Or else you can use the shift to first option, that will give the mean of the data here. Then second thing you have to find is the standard deviation of the population. So square root of summation x square by n minus mu square. So square root of here, so again press shift 1, first option, you will get summation x square, that is 234. So 234 by 5 minus here 6 square. So press shift 2, right? The second option gives you the standard deviation. So that is here 3.2863. Okay, now next we have to consider the possible samples of size 3 without replacement. So without replacement here, WOR is called the without replacement. So the formula is given by NCN. So here 5C3. So even that 5C3 also you can use using CALC. So give the value 5, use for C as a shift divided, then C will display, give the value 3 and equal to, so it is having 10. Right? So 5C3 is 10. So that means here we have to consider a sample of size 3 from the population without replacement. Right? So what is the sampling distribution here if we see? So sampling distribution without replacement is here. So 2, 3, 6 is one sample. Of size 3 means 3 elements we have to consider, right? Then 2, 3, 8 is one sample. Then 2, 3, 11. So that means from the first element, right? And the second element, the combinations are completed. So 2, 3, 6, 2, 3, 8, 2, 3, 11. Now you can consider the first element and the third element of the population. That is 2, 6, right? So you can write here 2, 6, 8 and 2, 6, 11. Okay? Then you can't write here 2, 6, 3 because we have written 2, 3, 6. Right? Then consider the fourth element, that is 2, 8, 11. Okay? Now again, you can't write here 2, 11, 3 because we have considered 2, 3, 11 here. So without replacement. Then next we have the second element as 3. So starting with 3, just draw the sample without replacement of size 3 here. So the continuation I am writing here. So 3, 6, 8 I can consider. Okay. Then 3, 6, 11 also I can consider. Okay. Then with the fourth element 3, 8, 11. And finally we have here 6, 8, 11. Right? So we should get 10 samples. Now there is no possibility to draw samples of size 3 without replacement. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the 10 samples are completed. Now next we have to consider the mean of these samples here. So mean of samples. Right? So now mean of the samples means sum of all observations by number of observations. So 2 plus 3, 5, 5 plus 6, 11. How many observations are there? 3. So 11 by 3. So 11 by 3 is 3.6. Next, 3 plus 2, 5. 5 plus 8, 13. 13 by 3 is 4.3. Next, 3 plus 2, 5. 5 plus 11, 16. So 16 by 3, 5.3. Next, 6 plus 2, 8. 8 plus 8, 16. 16 by 3 is 5.3. Next, 6 plus 2, 8. 8 plus 11, 19. 19 by 3 is 6.3. 8 plus 2, 10. 10 plus 11, 21. 21 by 3, 7. Next, 6 plus 3, 9. 9 plus 8, 17. So 17 by 3, 5.6. 6 plus 3, 9. 11 plus 9, 20. 20 by 3, 6.6. Then 8 plus 3, 11. 11 plus 11, 22. So 22 by 3, 7.3. And last one, 8 plus 6 is 14. 14 plus 11 is 25. 25 by 3 is 8.3 here. So we should get the 10 sample means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Okay. Now for this we have to find the mean of the sampling distribution of means. So mu x bar equal to summation x bar by how many elements we have? 10. So again just delete the data whatever you have given before and again go to the regression linear mode and give these sample means. Right? So 3.6, 4.3, 5.3, 5.3, 6.3, 7, 5.6, 6.6, 7.3 and 8.3. Now press shift 1. So summation x means summation x bar. It is 59.6 by 10. Right? So by 10 means here 5.96. So 5.996 means approximately 6 here. Okay. Then last bit we have to find the standard deviation of the sampling distribution of means. So square root of summation x bar square by 10 minus mu x bar square. Right? So square root of, press shift 1, first option 373.42 minus 6 square. So it is here shift to second option. So 1.3492. Right? So without replacement we have to consider the samples here. So mean of the population is 6. Mean of the sample distribution of means is also approximately 6 here. Standard deviation of the population is 3.28. Then standard deviation of the sample distribution of means is 1.34, which is less than the deviation of the population. So in this way we have to consider the without replacement of size 3. So remember here, if once this combination has occurred, we should not repeat it by replacing the elements. That is without replacement. If it is with replacement, we can replace the elements in the sample. Right? So that is the difference between the with replacement and without replacement. Now see one more problem on without replacement. Now this time here we have to find only the mean and standard deviation of sampling distribution of means for the population 2, 3, 4, 5 by drawing samples of size 2 without replacement. Means here in this problem no need to find the mean and standard deviation of the population. So here the population size is here 2, 3, 4, 5 means 4 elements and the sample size is given as here 2. So we have to find without replacement. So without replacement, WOR, without replacement. Right, the formula is here NCN, that means 4C2. So 4C2 means it is 10. So 4C2 is here 6. Right, so 4C2 is 6 means we should get the 6 samples of size 2 without replacement. So see the sampling distribution here. So 4C2 means here 6 samples, so of size 2. So only 2, 3, starting with the first element, then 2, 4 and 2, 5 here. Right? We can't write 2, 2 and even 3, 2 also. Then starting with 3 we have 3, 4 and 3, 5. And with 4 we have only 4, 5. So 6 samples of size 2 without replacement. Okay? Now next we have to find the mean of this sampling distribution of means. So find out the sample means here. So sample means 3 plus 2, 5. The number of samples are 2. So 5 by 2 is 2.5. 2 plus 4, 6. 6 by 2 is here 3. 2 plus 5, 7 by 2 is here 3.5. Then 3 plus 4 is 7. 7 by 2 is again 3.5. 3 plus 5 is 8. 8 by 2 is here 4. And 4 plus 5 is 9. 9 by 2 is here 4.5. So 6 sample means we have. So again go to the regression linear mode and give this 6 sample means in the calcium. So 2.5, 3, 3.5, again 3.5, 4 and 4.5. Now press shift 1, you will get the mean of the sampling distribution of means. So summation x bar by 6 here. So it is summation x bar is 21. So 21 by 6. So shift to first option is 3.5 here. Then second thing you have to find is standard deviation of the sampling distribution of means. So square root of summation x bar square by 6 minus here mu x bar square. So that means here shift 1 if you press summation x bar square, it is 76. So 76 by 6 minus 3.5 square. So this is given by shift to second option, which is 0.6455. Okay, so this is about the width without replacement here. So we have to consider the samples of size 2 without replacement. So you can't consider 2, 2 and 3, 2, 4, 2 also, right? So once if the sample is once we have given means that sample should not be repeated. The element in the sample cannot be repeated in that particular combination. So that is about the without replacement. Now let us see some more problems here. When the individual samples is given, then also we can combine those two samples and find the mean of those samples here. So if you have seen here, U1 is 3, 7, 8 means 3 elements are there in the first set, and U2 equal to 2, 4, only 2 elements are there. Then we have to find the mean of the first sample, mean of the second sample, standard deviation of the first sample, standard deviation of the second sample. Now if you combine the mean of the sampling distribution of differences of these two samples here, then we can calculate the mean of the sampling distribution of differences of means. So there we have used sample means. Here we are using differences. So that means here we have to consider the difference of U1 and U2, and for that we have to find the mean and standard deviation. Mu U1 minus U2 and sigma U1 minus U2 here. So you see the first bit here. So U1 is here 3, 7, 8. U1 is given as 3, 7, 8 and U2 is given as 2, 4. So first we will find the first bit, that is mu U1. So how many elements are there? 3 elements are there. So summation U1 by N1. N1 means here 3 elements. So that means here 3 plus 7 plus 8 is here 18. 18 by 3 is 6. Right? Then second we have to find the mu U2. So mu U2 means here by n2. n2 means the number of samples in the set u2 here. So it is 2 plus 4 by 2. It is 6 by 2, 3. Right? Then first we will complete the standard deviations of u1, u2 individually. Then we will go into the differences of both u1 and u2 here. Then here the fourth bit is here sigma u1. That means square root of summation u1 square by n1 minus mu u1 square here. So 3 square plus 7 square plus 8 square. So that means here 9 plus 49 plus 64. Right? So that divided by, so it is 122 divided by 3 elements minus 6 square. So it is given by the value here 2.16. So that means sigma u1 is 2.16 here. Now see the fifth bit here, we have to find sigma u2. That means square root of summation u2 square by n2 minus mu u2 square here. So square root of, so what are the elements here? 2, 4, 2 square plus 4 square. That means 4 plus 16 is 20. So 20 by 2 minus, what is mu u2 value here? 3. So 3 square. So 20 by 2 is 10, 10 minus 9 is 1, square root of 1 is 1. So sigma u2 is here 1. Now see that u1 minus u2. So u1 minus u2 means here 3 minus 2 is 1. 3 minus 4 is minus 1. Then 7 minus 2 is 5. 7 minus 4 is 3. 8 minus 2, 6. And 8 minus 4, 4. So how many elements are there? 1, 2, 3, 4, 5, 6. So let the number of elements in u1 minus u2 denote as n here. So n equal to 6. Now we have to find the mean of the sampling distribution of difference of means. So that means the third bit, mu u1 minus u2. So sum of all this divided by 6 here. So 1 plus of minus is minus, plus 5 plus 3 plus 6 plus 4 by 6. So this is equal to 5 plus 3, 8, 8 plus 6 is 14, 14 plus 4 is 18, 18 by 6 is here 3. Now the fourth bit, last bit we have to find is here sigma u1 minus u2. That means square root of here 1 square plus minus 1 square plus 5 square plus 3 square plus 6 square plus 4 square. Right? So summation of u1 minus u2 whole square by 6 minus here mu u1 minus u2 square here. So what is this summation here? So 1 plus 1 is 2 plus 5 square is 25 plus 9 square, 3 square is 9 plus 6 square 36 plus 4 square is 16. So it is 88. So square root of 88 by 6 minus 3 square is here 9. So 88 by 6 is here 14.6 minus 9. Square root of that gives you 2.38. Right? So in this way also you can consider the two different samples of different sample sizes. So here the size is 3 and there the size is 2. Right? They are clearly mentioned the distribution here, the with replacement, without replacement, or the difference or the addition. Means you can calculate the mean of the sample distribution of sum of means also. That is mu u1 plus u2 also you can find here. So in this way you can calculate this mean of the sample distribution of differences of two samples.